So thank you very much for coming and joining us today. And we want to talk about some of the work we've been doing on basically the low-level requirements for the Linux kernel and getting them into the documentation. This work, this is us, and we're all part of the ELISA Safety Architecture Working Group, where we've been tackling making this stuff visible and available. And it's going to be tying into work going up in the kernel's documentation directly, but also into the testing infrastructure. So we're basically trying to figure out how we can make this happen in a way that's going to be acceptable for upstream. For those who aren't familiar, the ELISA project is looking at what we need to do to enable Linux to be used in safety critical applications. That is our mission. And we are basically a set of study groups that look at various topics. And there's some code and some reference code we've been playing with and basically upstreaming for doing some of this work. But it is a way of those who have the like interests being able to collaborate in an effective fashion. So we don't have all the answers, but we definitely want to give you peers to collaborate with and places where we can sound out new ideas. And one of the ones in particular that's really relevant here is the Safety Architecture Working Group. And they were doing a lot of work with some of the cases and subsystems of the kernel. And then when we started looking at requirements traceability, this was a logical home for doing the work and building up from there, because at the end of the day, what the code is doing is its requirements. So we've been starting this work for a while now. In 2024 at Linux Plumbers Conference, we had our first session on this, and we tried to figure out what was going to be acceptable to the upstream kernel documentation. And realistically, other projects I work with have got a certain amount of different ideas, but we heard loud and clear that the kernel community wanted it in line with the code. And so that started us on a journey, and then they challenged us to come up with a template on how we can actually do all this. So we've been sort of working on this pretty much since Vienna, and we had a workshop at NASA where we presented a first draft of the template. And we got more feedback, which was very welcome, and have adjusted from there. And then we've been actually doing pilots in the working group of going through codes. There's a couple maintainers that said they'd work with us. And so we've been working with them, documenting it through, and we'll be talking a little bit about what we've been finding. And then we also talked about it at the ELISA Workshop last month. And we found out some more requirements as to why people might want this. And so working from the tracing subsystems and so forth. And so why do we attempt this? Well, we need to improve the quality of the code in the Linux kernel if we're going to be using it for safety, critical applications. It's very high efficient, it's very good code, but we need to be able to demonstrate it to people that it really is. And that's why the requirements in the testing starts to come into play. And we want to, quite frankly, improve the efficiency of their testing. We don't want to test everything on every commit. We want to be much more selective and resource constrained so that, okay, we know exactly which tests might have caused regressions we should work with. We also want to have the accuracy of the documentation improved. And, the kernel, a lot of our companies out there have been using Linux in safe critical applications, but they aren't sharing the information. It's within their own organization. It's all under NDAs. It's all worked with certification authorities. So we needed a way that we can do things upstream and, quite frankly, get people who have a vested interest contributing into it and hopefully having the maintainers review and say, yeah, that's doing what we think it should do. So we're working towards something like that right now. There's also a lot of technical debt in the kernel. Maintainers have moved on. People don't know what to do with certain subsystems. This is a problem from a security perspective because no one wants to touch that little tar bell, or that tar baby, I should say, to use a slang term, because then they own it. So we want to figure out how we can actually change this so that we can actually keep the kernel going and sustainable for the next 50 years. And this is a path for us. And one of the things that's really a hot topic is, okay, some people want to rewrite parts of the kernel in C, from C to Rust. Well, how do you know you're done? If we can come up with this framework properly, that'll get us a good way of the way there. So this is kind of why we're trying to attempt this. And with that, I'll hand it over to Chuck.
All right, let's start with some terminology like good engineers. Let's talk about forward and reverse engineering. So typically in aerospace, you start from a clean sheet design and you work your way up to something documented and then you implement it. Reverse engineering is you implement and then you document the design, okay? Iteration is involved in both of these. I'm making an overly simplistic statement here, but that's the order of operations. We are shooting for reverse engineering a very mature and not well understood design. That's the problem. So let's talk about bugs. A bug is a violation of expectation. It decomposes down to something didn't work right against your expectations. A computer will do what a computer is told to do. A computer did not fail to run the instructions. The computer ran the instructions exactly as they're programmed, but they violated your expectations. So let's talk about what a requirement is, because that's kind of a boring word. It puts people to sleep unless we think of it in terms of how do we test those expectations. Your requirement is a testable expectation. It's a shall statement, not a shall not, okay? Or you can say developer statement of testable intent, okay? Testable is provable. It shall. You cannot prove a negative. There's always corner cases. That's why nothing is secure. You're making it less insecure. Nothing is safe. You're making it less unsafe. Okay? You're trying to close that gap. And then design basically is just decomposition of your intent into pass-fail testable form. You start with a big idea. Maybe it's even your board of directors. It says we want a new car, airplane, medical device, whatever. And you decompose it down through the various disciplines. At Boeing, we have system engineers. Everything collapses down until the very lowest level you have code, okay? That is your lowest form of design expression is code. A low-level requirement, we're going to talk about those. So what is that? The guiding document that we use in aerospace, which it appears now that commercial aerospace requires the greatest degree of engineering rigor of everything else. That was as much a surprise to me as it might be to you guys. The guiding document that contains all the procedures and understanding, high-level procedures and understanding, this is DO 178C. They describe low-level requirements as software requirements from which source code can be directly implemented without further implementation. Meaning you could take someone, give them the low-level shall statement, lock them in a room, and they will come out with a correct implementation. You could lock 100 different people in 100 different rooms, and they will come out with roughly similar implementations. That doesn't mean while versus for, but it's still going to pass the test and do what you need it to do. That's the lowest degree of design rigor. Okay, let's talk about validation versus verification. Those are not the same thing. Okay. Steve Vanderleest, my colleague Steve Vanderleest, was the one who passed this on to me. He claims he is not the author. He is not sure who the author is. Okay? Validation is making sure you do the thing right. Verification is making sure you do the right thing. Okay? So verification, this violates my expectation. Okay? The code is incorrect. It traces to a pass-fail test. Validation, my expectation is wrong. The test passes. Everything works, but my expectation is wrong. We need to fix the requirement, which then trickles down to code. Code correctness is irrelevant. It doesn't matter. This is why traces to maintainer signed off by on a requirement patch text gives you some idea that even if the expectation is wrong, it's the understanding of the original developer. That's actually a virtuous place to be, because all the testing we have now, all the kernel level testing right now, it's an educated guess, unless you can show me evidence that all the testing being done has been signed off by the person who wrote the code. I don't think that's the case. Okay, so let's talk about bug-free code principles. Document all of your testable expectations. Just think of it in your head, right? Document everything you expect from the code. Now you trace testable expectation to developer intent. Maybe you got a signed off by, this is in a reverse engineering context, by the way. Okay? Then you develop a pass-fail test to validate testing with code coverage. So you have an understanding of what the code's supposed to do, testable, you can write a test, and then you can use code coverage tools. I'll be doing a presentation on Thursday about that. Code coverage tools to say, does the test cover all the code? And then at the end of the day, if the description of the expectation and the test and the code coverage all matches, you've got this virtuous cycle. That still doesn't mean that it matches what you expect, okay? But it means that the code matches intent. That's the most important part. Then you can iterate there and you know you've got everything in lockstep together. That's the most important part. Okay, let's talk about the problem statement, the thing we're trying to tackle. Because if we go into the solution too fast, people give these objections, and it's really important that they do. We understand that. So requirements and code comments, they do not compile. There is no compiler that compiles the code comments. No, LLMs don't count, okay? High-level design does not trace to low-level open source software implementation. So you're a car company, an airplane company, a medical device company. You've got a big idea. That's your high-level design, okay? There is no, at some point, your high-level, it'll break down into different levels of design, traceable design, till hopefully you're using open source software. There's no way to trace into where that open source software matches at the low level. There is no traceability there. So we have to solve that problem too, okay? Open source software maintainers, we cannot burden them with additional process overhead. That's just a non-starter. Now, there is an argument to be made that should we be successful, this will reduce their overhead so much that they'll be happy to take on burden, but people sell snake oil all the time, okay? And I'm not asking for free money here. So I'm saying what we're trying to do is avoid any burden on open source software developers. If we achieve what I think we can achieve, and it is audacious, I agree, then they will see a commensurate decrease, and we will have never had to ask them to do extra work to do this, okay? Proprietary solutions are infeasible. Open source software moves way too quickly. 9 commits an hour, right? That's what's rolling into the Linux kernel. Last time I talked to Greg. Linux achieved world domination, and reliability pressures are immense. I just noticed one of Linus's latest, this is the latest release at the very bottom. How did he finish it, right? Keep on testing, right? Right? There's a reason why he's saying that, right? This is really important. But remember, all the testing we're doing, still an educated guess. So we have a template that maps to all these problem statements. Let's talk about other requirements we have, okay? We're going to avoid substantive changes to current Linux kernel development processes. That means we're designing something that can be decoupled from the maintainer's workload. Yes, that means requirements may be lagging behind implementation. That's a feature, not a bug of this. Couple of reasons for that. Coders, maintainers, may not be great requirement writers. They may not have enough time to be a requirement writer. All we're saying is there's a reason, so based on the design of this template, we're creating the ability to tell when code needs to be re-reviewed, when requirements need to be re-reviewed, and the way you can document traceability through all that. Each requirement has to have a stable ID. This allows for anybody with high-level design to trace down into low-level kernel implementation. OEMs, anybody. Each requirement shall have to have a hash key that tells you when something important in the kernel source code has changed, and it will draw your attention to it. This allows you to decouple maintainer activities from design work, reverse engineering work, okay? And there's some details, you can read the rest of this yourselves. But there can't be any coordination between these stable IDs. That's a complete non-starter. So they have to be derived algorithmically. And then it has to be a machine-readable template. And I think, yeah, and there has to be references. You have to be able to reference. So that's about the traceability. Okay, so let's talk about the proposed template right now. We have one in work. We have a lot more work to do. We're working on a white paper to explain it fully. A lot of the work we're doing, reverse engineering kernel code, leads us into areas where we say, the template's inadequate here. We have to come up with a way to address this issue. We have come up with multiple versions of that. So here's the proposed template tags. These are proposed. They are not even close to being done, okay? Your requirement ID is your stable ID. Then we're considering beginning and end. So requirement ID would be the beginning, end would be the end, sentinel. These would be in the form of code comments, either kernel doc or inline. You got a reference. So the kernel is a very polymorphic tool, okay? It has to be because it supports a lot of different architectures. And so it's not so convenient in a forward engineering design where you say this function will stand alone. There is a lot of referencing involved. So there's got to be a way to reference other code and other implementation within the kernel to say this is directly related to this particular code. So we have to have some way of saying this is a reference. Your hash key is how you're signaled. When you have to worry about changes to your implementation, you have to check your wording. And then there's child traceability, and then to tell when one requirement traces down to a lower level requirement. Subsystem, obviously that's per open source project, that's going to be different, but the Linux kernel has kind of pioneered the idea of maintainable subsystems. That's where we got that from. There's the requirement text. That's your shall statement. That's your testable, statement of testable intent. And then anybody who's worked on requirements know there's always these explanatory notes you occasionally have to do. Because if you didn't have those, you would have to like lawyer your requirements so much that it would make no sense to anybody. So it's a nice tool. It makes everybody's lives easier. Okay, so the line format, kind of UTF-8, this is kind of the regular expression for it. We're trying to avoid any text processing or escapes. It really should be human readable. Trying to do the common sense rule, 80 character common sense rule. Trying to avoid all the stuff that you shouldn't do in code comments. We still have the work to do on grouping, enumeration, offloading, those kinds of things. So we'll speed through some of these. This is the idea for generating your stable ID. So this is just the echo statement here is an example. It's not actually how we're going to be doing it, but allows for tooling to sort of combine enough information that you can uniquely tie the code itself with the requirements, and that way you know when there's a change that needs to be checked. This allows for a CI system to alert somebody. If you're a requirement maintainer, this is where you would get your email saying, hey, code change, you need to look at that. Maintainer doesn't do requirements. They just accepted a patch. They agree to include this, but they're not worrying about requirements. So this is where the lag comes in. This is where you are alerted to when the change needs to be addressed. Okay, the hash key. So I'm sorry, when you first create requirements, the stable ID and the hash key will be identical. Okay, they're hashed the same way. Later on, the stable ID stays the same, but the hash key is what changes. You calculate, and if it doesn't map, just like when you're hashing a password, right? Doesn't map, then you know you have to check and make a change, potentially. Even at a minimum, you're just updating the hash key. Okay, this is your entity relationship, your child tag. It's acyclic, there's no loops. And then this is your subsystem, just a text. Usually here for Linux kernel, it's the maintainers file. This is the text to the requirement, and Gabriele will talk more about that. It's got to be human readable. And then this is your intent, your enhanced reasoning, 0 or more. I think that's all it for the tags. I'll pass it over to Gabriele. He can talk more about the semantic aspects of generating requirements.
Yeah, thank you, Jacques. Okay, so now you got briefed about the, every single ID, every single field in our requirement template. One thing to be noticed, probably was not mentioned, is that some of these part of the requirement are to be documented directly in line with the code, whereas some other parts will be implemented in a sidecar file. This is to avoid cluttering, the source code and having something that is maintainable. Okay, so indeed, at the end, from a semantic point of view, what's important? Indeed, we need to document what is the expected behavior of the code in a way that is testable, as we already mentioned, and maintainable as well. And now, the key challenge here is, when is enough? So we, during the architectural working group, especially with the initial set of functionalities, we had many iterations of writing requirements. And the very first solution that we came up with was really ugly. It was really a sort of pseudocode that was rewriting the current implementation, and that was really, unacceptable. So after different iteration, we at the latest ELISA Workshop, we discussed with Steven Rosted, and we presented him with 2 different possible solutions. One was more high level, and another was more low level in terms of detail of expectations, and we decided to go for that solution. And indeed, our starting point is the kernel doc headers. So we have tried to write requirements in a way that is compatible with the current kernel doc header formats. And in a bit, I'll show you some examples. Then, what are the elements that that are important to be documented, right? And this is what we've captured. So the input parameters, these were already part of the kernel doc headers. State variables, these are global and static data that are impacted, that are touched by the code being documented. Software dependencies, so external APIs invoked by the current function. Hardware dependencies, so any hardware design element that can impact the behavior. Firmware dependencies, like that are the firmware elements that that can have an impact on the behavior, like device tree blob, ACPI tables, or runtime services like CMI. We have compile time configuration parameters and runtime configuration parameters. So all of these elements are possible candidates for the documentation of our code expectations. And then we have the design elements impacted by the expected behavior, that are the return values, the input pointers, state variable that can change their value after the code is executed, and also hardware design elements that may have changed their status. And to this extent, there are some consideration that we need to make. Indeed, as we already mentioned, our requirements must be testable. And in that regard, all the elements that I mentioned in the previous slides must be documented in a way that, where it is clearly specified what is the impact of the input elements toward, the cause versus the effect, effectively. The scalability consideration. So if we try to document a syscall, for example, it's impossible to document every single aspect that can be reached, from a syscall, because a syscall can go everywhere inside the Linux kernel, right? So therefore, we need to find a way to write requirements in a way that is scalable. And to this extent, we need to consider all the different dependencies, that must be, so effectively, we will write requirements in a hierarchical way, okay? And then finally, there are feasibility consideration. If we try to document every single aspect of the code, we come up with a pseudocode. So effectively, a sort of different implementation of the same thing that is documented, and this is not acceptable. So in this regard, the Linux experts and the maintainers, here they need to play a very important role in deciding, what is relevant to be documented and what is not. Okay. Okay, good. So what have we done in practice? So till now we talked a lot, about philosophy, I would say, and about intents. And now, let's see what we've done. So first of all, we have created a branch, a clone of the Linux mainline branch into the ELISA GitHub. And this is where we have started prototyping our requirements. Following the ELISA Workshop, we got a sort of informal approval from Steven Roasted for us to work on the tracing subsystems that he maintains. And what you're looking at here, here we have a set of functions that we have documented. Now, I think we can click on one of these, I hope. So I can show you effectively what an example, if I manage to. Right, so I don't know if it's big enough. If not, it's a bit hard to zoom from an extended screen. I managed. Okay. Okay, so consider that in this first implementation of the requirement, we have focused more on the semantic aspects rather than on the formalism of the template, because there is always time, to adjust, the rec ID and all the other tags. Okay, now the most important thing was to understand from a semantic point of view how to write these requirements. So effectively, we focused a lot on this SPDX rec text. Now you can see that here we have a function description in a kernel doc header format. We have the function name here, and on the right, short summary. We have the input parameters here. So here we have the file pointer associated with the target trace event, user space buffer where the event status is copied to, number of bytes to be copied from to the user space buffer, and then pos, the current position in the buffer. Then we have a short summary. So this is a way for user space executables to retrieve the status of a specific event. Okay, so this is what the function does. And then we have here we have the list of function expectation. And here, all of these are written in a way that they are testable even if you don't read the code. First of all, this function shall lock the global event mutex before performing any operation on the target event file and unlock it after all operation on the target event file have completed. This function shall retrieve the status flag from the file associated with the target event. This function shall format the string to report the event status to user space. And here we have all the description of how the string is to be formatted. And after that, we have the function shall check if the requested CNT bytes are equal or greater than the length of the string to be copied to user space. Else a corrupted event status could be reported. And this function shall invoke simple read from buffer to perform the copy of the kernel space string to ubuff. And then here we have the detailed description of the return value. Okay, in case of success, and also the other one in case of error. And another thing to consider here we mentioned as part of the error return value, error returned by simple read from buffer. This means that we expect to have another requirements, associated with simple read from buffer, so that if you want to, understand from here which error can be returned, you need to go and look into that function. Okay, so this is, just an example. I will not show you the other ones because otherwise probably we'll run out of time. But this is what we've done, and this has been pushed as an RFC to the tracing mailing list. Okay, let's go into presentation mode again. Okay, so what we've done, as I said, we have created the requirements proposal for this function. We also created an initial automation to populate SPDX rec ID identifiers within the source code. So if you remember, as Chuck said, SPDX rec ID is generated based on different fields, and we have created an initial automation to generate automatically this SPDX rec ID. While we wrote the requirements for the functions in point 2, we found a bug in ftrace event enable disabled. We pushed the fix, and that has been accepted upstream and also in the LTS branches. And last but not least, we pushed the RFCs with detailed kernel doc headers associated with all the functions as per point 2. And these are currently being reviewed. Okay, so this is where we are now. Yeah, lessons learned. As already said, it's very, very easy to end up writing pseudocode, and requirements instead should be agnostic of the implementation. This is also something that Chuck talked about. So the Linux kernel is complex, and very often multiple requirements map to a single function. So I don't think there is any single function that I have documented with a single expectation so far. Probably there are some very, very simple functions that can be documented using a single requirement. And another important part is that in order to get the requirements framework accepted upstream, it is better to show the value first. Now, this is a very important point. I said, if we go back here, so what I said in this slide, I say that we have pushed upstream the RFCs with the detailed kernel doc headers associated with the functions as in point 2. This is correct. However, if you open these RFCs, we have no SPDX, RecID, nothing like that. So these are pure kernel doc header that are documenting just the function documentation. So just the function expectation. So without, anything from the template that was presented by Chuck. We have done it because we believe that first we need to show the value of having documentation around this function, and then we can propose a requirements framework, to maintain the requirements, to trace them to the kernel CI testing, for example. So so this is why we are operating, in this way. Next step, we will continue to use the SPDX rectext section of the kernel requirement to create documentation patches. So this is already in progress for the tracing subsystem, and now the new Gania pig will be driver char mem.c. So this is part of the char and MISC drivers subsystem. The reason why we are also now we will be experimenting on driver char mem is to also bring more maintainers and the respective subsystems on board. And we want to have more people joining these requirements efforts. So if any of you is free on Friday, are you busy on Friday, 10 a.m. Eastern time, or it's like 4 p.m. Central European time? So if you're free and you feel brave enough, please come and join the architecture working group that I lead and help us. Another thing we want to do is we want to work with the kernel CI to link requirements to the testing infrastructure. So this is also our next step. And finally, we hope that with this work that we are doing on the requirements, we will refine the current template and tooling, and we'll be able to present something at the Linux Plumber in Tokyo, and so that we can define the final steps to get these requirements framework upstream. And so this is our the call to action. Here you have all the details. So take a picture. So many people taking picture of the requirements template. This is where you should take a picture instead. And yeah, so if you are familiar with the kernel subsystem, please, start prototyping requirements and send pull requests to the GitHub branch that I presented previously. Okay, and then together, we can send RFCs and patches to the mailing list in the Linux kernel. And also, yeah, if you are, where is Gustavo? Yes, here you are. So yeah, another thing that we can start doing is we can start linking the code expectations that are documented with pre-existing tests. Okay, so yeah, okay, we can work on that as well. All right, so thank you so much for coming, for listening to us. Any questions? Please. Yeah, Jonathan. Yeah.
You showed a variant of the kernel doc comment format with your new tags in it. Interpreting those tags is not part of the requirements for the existing kernel doc script that interprets those comments. Do you have patches so that you will not actually break the kernel documentation build with those extra tags in there?
Thanks, Jonathan. So yes, you're right. No, at the moment we don't. In fact, what we want to do first is we want first to refine the template focusing on the semantic aspects, and then yeah, we need to work on these aspects on this aspect as well. So we need. I think today this will be just pulled as they are, right? So it's no, they will just go. They will break the compilation. Okay, so then we need to fix that. Yeah.
One piece of color during development, we noticed that there was we're not going to do it, but the adverse potential of 12 different requirements where you're just changing one thing, right? This shall be this, under this, that kind of, that's not going to work. So that's one of the things that we find as we're going through actual code, we're finding the corner case and we're saying, well, we can't do 12 requirements that say more or less the same thing. We have to come up with a mechanism in the template format to say, here are the variations you can expect on that. And then if you're an OEM who cares about literally word for word everything, that's a scripting thing that they can do. So there's just a sense of the problems that we're running into in all these corner cases. That's why we're trying to take it slow and mature this as we run into code examples that, oh, how do we template that? We don't know how.
Yeah, exactly. But after we get initial consensus, after we got something semantically accepted, and what we pushed, they have nothing. I mean, they have no. I mean, I can show you the RFCs that we sent out. There are no SPDX, nothing, right? So it's like pure kernel docker. Once these make their way upstream, then we'll refine all the tool chain, and yes, we need to probably consider also these aspects.
Please post your proposals for changes to the kernel doc comment format widely to the Linux doc mailing list and beyond, because people will surely have comments, and some people will surely see it as needless cluttering of things. You'll need to justify it. Expect some discussion. And so getting started on that sooner, even before you've fully nailed things down, may make your life easier later on.
Okay. Do you think, like, we have a white paper going? I haven't been able to, I had to take a delay. I'm finishing a master's degree, so the summer I'm trying to finish it up. So like, I'm an artist, right? I don't want to put it out till it's ready. I know you understand this feeling, right? Just throw it out there. I mean, is that what you're saying? I mean, I don't think so.
I don't think it's as easy. Yeah. I mean, if I interpret Jonathan's comments, first we need to have a proposal that is also able to build the Linux kernel documentation from the new templates that we are embedding in the kernel docker.
That is part of it, but have a proposal that just shows what it's going to look like. And then, for example, mark up the scheduler comments and send them to Peter Zylstra. And if you can get them past him, then everything else will be very smooth sailing. I'm seriously, getting the tooling working is important, and we need that. But also, kernel developers want to see what it's going to look like and what they're going to have to deal with going forward. So the sooner you can give an idea of something that you're going to be expecting of a lot of developers, I think, at some point, to at least accept and merge, if not maintain. So getting their eyes on it sooner would be, I think, will make your life easier in the long run.
I will definitely echo everything John just said. Sooner, if you send it sooner, people will see it. We have done this. We have experience with going from text format to RST for documentation. That took a long time. And we have had to maintain, we are still maintaining .text files because some people don't want to go to .rst. So I would say keep sending these and incremental, just follow the kernel process so that it makes it easier for you. Because you could be writing it, but you're not getting the input from your people who you want to have this consumed. So as long as you don't do that, you're not getting real feedback. You're kind of sitting in your echo chamber listening to your stuff, and you're not just getting feedback. So I would say do that. And the other thing is also think about how, right now you are just working with taking functions that are working, fully mature code. Also think about how it would integrate with kernel development process where we don't really think about this because it evolves. We think we did the design. All of us do this, all developers. We say we have an idea, we got it working, and we go out there. It will look very different 2 versions or 3 versions down the road. So how do you do that? Are you churning requirements constantly? How are you doing that? Think about that aspect as well as you are coming up with stuff. Those are the questions developers will ask.
Thank you, sure. But now I have a practical question. So what you're saying, so my question is it acceptable to send out on the mailing list, on the documentation mailing list, a sort of work in progress proposal that by definition cannot be merged, right? But just to show what is the intent and how things could look, do you think it's acceptable? Yeah? Okay.
I mean, we're talking about the template, and we're still running into corner cases that the template doesn't address. So some of that is, I just was worried about getting a bad reaction and then getting written off after that. Before we have anything that's too mature, I realize we can't analyze forever. But there's also, we're writing actual requirements, and those are on the list now. You can see them. There are RFC sets of requirements that pass kernel doc that are there. So there's 2 different things we're talking here.
So I think one thing I picked up on in your presentation is that you found a bug. So that's good. So that is your selling point and saying we did find a bug. So what I'm saying is that you do need to, don't wait forever. That's the first thing any kernel developer would tell you. Even if it is, you don't think it's right, RFC is great, and start adding those. And another thing I would say is, just keep sending. Even if you don't wait for you have some goals. You wanted to get it right. And you are selling this to a community that does not want to see things cluttered. So you want to bridge the gap. So the way you do it is slowly. Boiling the frog example, boil it slowly. So send incremental code and say, hey, this found a bug, so we think this will be useful for you. And start sending that. And then also another thing is we do have currently some documentation. I don't know about tracing subsystem, but we do have some well-documented API. You can take a look at it and see what we are doing already, some of the stuff. I think you will probably find it in media subsystem. They describe it's a rudimentary description of return codes, and it just says, yeah, it returns this. So also take a look at those examples as well. So if it is in your Git, nobody's looking at it. Until it gets into the inboxes, the right inboxes, nobody is looking at it. So that's what I'm trying to say.
There's another question.
Are you going to ban the word not and the word and?
Say it again.
be testable.
Okay.
So
I'm just saying ban the word not and ban the word and. Make your life a lot easier. We're going to script the parts of that.
Yeah, I don't think in any requirement that I wrote there is the word.
logical inversion, so that's okay. I mean, that's still legal. So anyway, yeah, talk to us after. Yeah, you got one too, right?
Speaking of testable, I see a lot of criteria that in this proposal for testability. Have you, maybe you already do it, have you thought of automating some of these tests of the documentation?
I mean, we are not testing the document. We are testing the code that is documented, right? And there is a project that is the kernel CI project that is from the Linux Foundation and is co-led by Gustavo, right? And the goal of this project is to put together, as many tests as possible, for the Linux kernel. What we need to do, we need to link this expectation to the existing tests and find the gaps. And for the gaps, we need to write new tests, and so on and so forth. And new requirements, yes. I don't know.
I can start first. There's no doubt about the positive value of adding this. I'm a little bit concerned about the fact that, you mentioned a lot of the kernel code is reverse engineered into the requirements versus the requirements coming in as a part of forward engineered brand new drivers, brand new files that might be created. So, you mentioned the requirements sometimes come from completely random different parts of the Linux kernel for a given file that may not be fully tested. So a developer in a distant future might rewrite the code looking at the requirements line as a requirement versus a redocumentation of the same file and inadvertently introduce bugs in the code because they're going with that requirement line versus...
That means the requirement was poorly written.
Right.
So they both should reinforce each other.
Yeah.
So re-implementation, failure to re-implement, means that your requirement wasn't written with enough clarity that you could just look at that by itself and implement the code.
Right. Yep. I can think of an example of an audio driver that worked for one evaluation board, but actually didn't work for a different evaluation board because somehow the timing of the function worked. So if that was put in the requirements file, call requirements, a future developer might make it work with the current board thinking now the requirement's been satisfied, but you're right.
Every time you say it didn't work,
Yeah.
that's when you go back to say, in some magical parallel universe, literally every expectation we have is written down and no one's using the words it didn't work. When it says it didn't work in this universe, it wasn't written down as a requirement. That expectation was not documented.
Right.
Yeah. So this will force that virtuous cycle.
So if I understand correctly, with this proposal, you would be documenting the expectations of behavior, the requirements, but then the actual evaluation of those requirements would be handled by the kernel CI project.
So I don't care who handles them, right? I hope kernel CI does it. But this is audacious. This is almost grandiose, like I need medication when you look at how big the kernel is. I get it. I understand that. But once you have the kernel maintainer agreeing that, yes, that is exactly what I think the code should be doing, then another person, CI, anybody can come along and write a test.
I agree and I understand that. I suppose the direction I'm coming at this from is I do a lot of documentation testing. And one of the problems that I've seen people run into is drift between the documented requirements in your case and what's actually being tested. But how do you ensure that via hash that the test actually satisfies all of the requirements as they are initially written?
So that's where you get the traceability. There's three ways to evaluate the outcome. It's correct, incorrect, or unknown, okay? You have to get rid of the unknown. All we can say for sure is it's correct or incorrect. If it's incorrect, that means the hash doesn't calculate the same, which then calls into question the test that traces to that requirement as well. Then somebody knowledgeable has to go through and go, oh, no, that was just a spelling change. It clearly did not change it. Update the hash, we're good. You'll see the commit in the commit log. Everybody move on, test is fine. And you can imagine all the other scenarios that go along with it. That's why you have to have, you can't compile English prose. LLMs don't count. So you gotta have a way of locking it in from English description to code to test to code coverage and all that stuff, and that's what it's for.
The documentation I saw there looks very much like the manual pages. So I would like to know why do you write it as comments instead of a manual page where you would add a section with the hash or something?
You have to trace to higher level design as well. There's a traceability.
So the man page is dedicated to the glibc APIs, pretty much.
In the FreeBSD or in the BSDs in general, they have section 9, which covers kernel internal. So you could write section 9 manual pages.
But no, but the thing is when we
Add them to it. I mean, it's just stuff.
no, the answer is that we discussed this with the maintainers at Plumbers in Vienna, and basically the feedback is we need to have requirements embedded in the code because they want to be able to review code changes against the requirements without, and in fact, one of the challenges right now, the man pages is not maintained on the same branch as the Linux kernel. So that already poses a sort of challenge. So.
And once you have a template, you can add it. You can create man pages if you want.
Yeah, the thing is, if you have comments in source code, I find it less readable personally. Yeah, me and many people find like if you have a lot of comments in source code, then the code is less readable because you have to skip it. I don't know.
Yeah, the requirements are different. It tells you what your expectations are. It's not the same. So anyway, we can talk more. Thank you, everybody.